Hello, Year 11. This is a night before news for design and technology paper that you'll be sitting tomorrow. On this slide here, I've just put some topics that will be involved in this paper. As you're all aware, there's 3 sections to the paper, section A, B, and C. Section A contains multiple choice and some short answer questions, hence why it looks like there might be quite a lot of topics involved in that section. Section B, you've got calculations, there's quite a few maths, but also there's questions where you're expected to explain a commercial process. You talk about tools, production systems as well. We've all gone through most of these topics anyway, but I will go through them again just to remind you of what's included in there. And then in section C, it's long answer questions again that are about 6 marks, 4 marks, 10 marks, and also what's included in there is the it's orthographic drawings and 1-point perspective drawings. So there's always going to be a drawing section or question in section C that you've got to go for. And also what we always see is a question about environment and ethics as well. So section A is at 20 marks, so you're requested really or expected to spend about 20 minutes on this section. As I said, a lot of them are multiple choice and some short answer questions, so you don't want to be spending too much time on this section really, as you need to move on section B and C, which has got longer questions and some drawing techniques as well in there. So the first section we're going to be looking at is about materials, and specifically this time we're looking at composite materials. We have gone through composite materials, so I'm just going to give you 1 minute just to see if you can answer that question. What are composite materials? Pause the video. Composite materials are a combination of 2 or more materials. It's not the same as alloys, because alloys are metals and alloys are a combination of 2 or more metals. This time we're focusing on general materials, any other material. It's a combination. Composites are a combination of 2 or more other different materials. So the next question I guess that comes up is, what are the examples of composite materials? And again, I'm just going to give you about 20 seconds for you to try and answer that questions, and pause the video when you're ready to do so. Examples of composite materials are carbon fiber, glass reinforced plastic, Kevlar, and plywood. Some that we spoke about: glass reinforced concrete, and just concrete itself is a composite material because it's a mixture of cement, sand, and water, okay, and aggregate as well in other cases. So these are all examples of composite materials because there are 2 or more different materials involved in the making of each one of these. Now in this slide here shows you all the composite materials that we have discussed. On the left hand side here shows composite materials and the examples that we've all gone through and their uses as well. But the one that we've gone through in length is this one here, which is carbon fiber. But it doesn't mean that's the only one to look at and try and remember. There are other ones like Kevlar, which we've gone through in length and spoke about as well. And concrete as well. We have given example with some of the concrete slabs that are in our classrooms. But the one here that again that not many people know about and we said about is plywood or other manufactured boards, because here if you think about it, it's wooden pulp mixed with resins, which makes it a composite because there's 2 materials they mixed up. Resin are mainly plastics, hence why wood chips plus resin, which is a plastic based material, then makes manufactured boards composite materials. So still looking at polymers, my next question is, what are thermoplastics? and what are thermosetting plastics or polymers. I'm just going to give you about 1 minute to answer those, 30 seconds on each to try and answer those. Please pause the video when you're ready to do so. Okay, so thermoplastics, we know, are the plastics that can be heated, formed, and reheated repeatedly if you make a mistake. We use acrylic in schools as, because it's a thermoplastic that allows us, if we do make mistake in the classroom, we can reheat it and reform it again. If we still make a mistake, we can reheat it again, and it's that flexible in that way that it gives us an opportunity to fix our mistakes if we needed to. But also it is recyclable, because once you finish using it, for whatever reason you've been using it for, it can be taken into recycling center where they can heat it and form it into a different component. Okay, so thermoplastics are the ones that can be reheated, formed, heated again repeatedly, and because they allow you to do so, they then become quite easy to recycle. Whereas thermosetting plastics would not allow you to reheat them again. They are therefore not easy to recycle, and they're very brittle. And what that means, they'll break quite easily if they're put under pressure. So in this slide here, it shows us some examples of thermoforming plastics. The one that we've been using, or we spoke about in length, is the acrylic, which we used in quite a number of projects in product design, really. We've also used HIPS plastic, which we used in the process of vacuum forming, and you've all done vacuum forming towards the end of year 10 when we're making the robot project. Another that we said about is the PET, polyethylene, okay, that we said about. It is used in drink bottles, but also at the top of drink bottles on the lids, they use HDPE. Another example, or another good one that we see a lot, is the PVC, which is used on electrical plastic pipes. Underneath here is an example of some of the thermosetting plastic, and as we discussed, we spoke about resin as an identifier of what thermosets are. A lot of thermosets are resin based, so anything that comes up to you as a resin, you know is a thermosetting plastic. But also we spoke about melamine formaldehyde, which we said we can see it in as worktop surfaces at home. A lot of our worktops at home, they would have used melamine formaldehyde, but also urea formaldehyde, which we see a lot in electrical fittings. So electrical sockets, those casings would be made out of urea formaldehyde. So I mean, I guess to think about thermosettings, anything that's got a resin in would be a thermoset. Anything that might have a formaldehyde is also a thermoset. So now we move on to manufactured boards. We have used most of these manufactured boards, and we know manufactured boards are made from timber waste that is then mixed with resin or adhesive to create these man-made boards. We have, during the making and product design, used MDF, medium density fiber board, but we've also used plywood. Now, MDF is basically made from very fine fibers of timber that are left from the sawdust and so forth, collected, mixed with resin, and then pressed to form MDF. Whereas plywood is made from layers of veneers, not from waste wood, but from natural grained layers of wood that are then joined in opposite directions to create this very, very strong material. Okay, so that's that about manufactured board in a nutshell. On the right hand side, the next topic we look at is planned obsolescence. And planned obsolescence, we said, is where manufacturers design and make products so that they can break or be obsolete either in 2 years, 3 years. It depends on just how long they want those products to be absolute. And we know an example with iPhone, a lot of the old iPhones now, even though they're still, solid and strong, and most of the past content, they don't work now. And it's because the manufacturers have made sure that the old phones don't work at all now, so that the new phones are weakened by the new phones, as the old ones would then be absolute.